the search for Martian life isn't over. In preparation for future expeditions to Mars, scientists are studying another harsh corner of the solar system. Welcome to Mono Lake, California. On the eastern side of the Sierra Nevada mountains, this is an otherworldly realm. Jack and Maria Farmer are paleontologists of a sort. It's not dinosaur bones they're after. They work for NASA, and they're setting out to discover an extraterrestrial empire of microbes, the kind that may have thrived on Mars in its early days.
Most of this area where we worked last year, the water levels come up and covered the spots, so we'll have to try to relocate everything. My feeling is that life could well be just a byproduct of solar system evolution. And wherever you have the right kinds of environments, namely liquid water and the right mix of organic compounds, that life will originate and get going.
Mono Lake is stocked with a kind of primordial soup. Encased in its rock formations are primitive organisms. Billions of years ago, they were among the first life forms on our planet. Remarkably, this basin has much in common with Martian craters formed by large meteors.
This spot on Mars, called Gusev Crater, we think is a place where there was once a lake. And the commonality here is that all of the streams that flow into the Mono Basin end here. There are no outflowing streams. It's a terminal lake basin. Water comes in, but it only leaves by evaporation. If you look at Gusev Crater on the surface of Mars, you see the same sort of thing, where you have a big channel flowing in, but nothing flowing out. So it was also a terminal lake basin.
Along these banks are towering rock formations known as tufa. They are rich in carbonates, a mineral that forms when salt and fresh water meet. These microbial spawning grounds make Mono Lake a living laboratory for primitive life forms.
Okay, Maria, this tufa is very porous. It's large cavernous openings. And these basically are spring deposits. They form where water flows up into the lake floor. And these structures, as they form, entrap microorganisms and preserve them as fossils.
At the microscopic level, the remains of tiny microbes are encased within layers of minerals. It's fossils like these that NASA hopes to find on Mars.
During this early period in Mars history, there was a constant rain of organic molecules onto the surface being delivered by comets, by interplanetary dust particles, and so on. And at the same time that was happening, we also know we had liquid water available at the surface. Life could have originated on Mars because we had all the basic ingredients: liquid water, all the organic chemicals, and enough time.
In our search for Martian life, we may be only scratching the surface. Deep underground, living microbes may still flourish there.
And where do we go to find extant Martian life, if it exists? I think that the most logical place to go is sites associated with volcanism. And if you have a hot spot, water in the crust, that water will at some point be melted. And that's the sort of setting we have to be able to seek if we're to seek life on Mars. I don't believe that there's any standing water on Mars. We must be prepared to drill for it. Or if we find open volcanism on Mars, open volcanism is manifested by fumaroles, steam vents, for example. That's also where the very earliest life on Earth was.
If it turned out that the biochemistry of Martian life was fundamentally different from that of Earth life, it would show that life can emerge and evolve in more than one place. And it would, I think, strike at the very heart of the basic paradigm on which our understanding of biology is based, which is that it's a result of just a sequence of incredibly improbable accidents.
To find other life in our solar system, we may have to prospect for it, and Mars may not be the only place to dig. The conditions of life may also exist on one of Jupiter's moons. Beneath Europa's crust, scientists believe, is an ocean of volcanically heated mud, just the kind of environment that can spawn primitive microbes. The turbulence churning below is written across a veneer of ice. Europa's surface is rent with fractures. The spacecraft Galileo recently sent back images of a zone bulging with spillover from the moon's roiling interior. If life exists here, then who can doubt it also has emerged in the universe beyond? Today, we are searching for alien life with new technology and new energy, but with the same optimism that once buoyed the hopes of Lowell and Todd.
This discovery of planets that's going on now is opening up this whole field for further study. We can discover other solar systems, then we'll know where to point.
Two San Francisco State University astronomers say they've discovered yet another planet outside our solar system, circling a star some 40 light years from Earth.
Astrônomos americanos anunciam a descoberta de dois planetas.
The word is out.
Perto do sistema.
We live in a solar system ourselves, and we know that life...
우리는 태양계 내에
In a string of announcements, Jeff Marcy and Paul Butler have unveiled the discovery of 3 new worlds around nearby stars.
태양계 밖에 다른 행성에
The names Butler and Marcy are in the news. These latter-day Columbuses are hot on the trail of new planets. All they need now is a press agent.
Hello, you have reached the office of Jeff Marcy and Paul Butler. Please leave a message at the tone. Hi, this is a message either for Jeff or Paul. This is Mike Shapiro with the magazine Web Review. We're an internet publication, and I'd like to talk to you, hopefully within the next couple of hours, about your discovery and your publication of it on the web.
Hi, my name is Leslie Corin, K-O-R-E-N, and I'm calling from KPIX Radio in San Francisco. I was hoping to set up an interview with you tomorrow morning about your new planet. My number is 415-765-8701.
This radio thing ain't gonna happen.
We're swamped. I got 3 or 4 calls from TV stations this morning, and I told one of them at 1 p.m. I'll be free. But, you know, the problem is that we have an enormous amount of work to get done right now. We have proposals to write. We have planets waiting on our hard disk, which we just need enough time to analyze. And it's sort of a catch-22, and, you know, the media is, you know, taking up our time, which is preventing us from doing what it is the media wants to talk to us about. It's kind of curious. So.
The public is clamoring for news of other worlds, with its expectations perhaps shaped by those planets we know. 9 companions move around our sun in nearly circular orbits. Inner planets, such as Venus, are subject to the searing heat of the sun. Jupiter is one of 4 gas giants that skirt the fringes of the solar system. They are no place for life. But the 3rd planet out boasts a remarkable combination of attributes. It's just the right size, set in the right orbit, at the right distance from the sun. It passes its time squarely in what scientists call the life zone. But are there other solar systems like ours? Marcy and Butler offer some answers in the planets they've found.
The one around 47 Ursa Majoris is a planet of about 2 Jupiter masses. If you put that planet in our solar system at the right distance, you'd say, gee, that looks like a normal planet. On the other hand, we are seeing other planets around these other stars that really look very, very different. Some of the planets are in too close. We have 2 planets that are extraordinarily close to their star. And we have 2 planets that are in orbits that are non-circular, very eccentric, elongated orbits. And we don't see planets like that in our solar system.
This is one of the most important revelations of Marcy and Butler's discoveries. Most planets discovered so far, it seems, do not inhabit solar systems like ours. 55 Cancri has a planet the size of Jupiter, but it's so close to its sun it races around it every 15 days. A planet orbiting 70 Virginis is 6 times heavier than Jupiter. Its path takes it drastically close to its star, then swings it wide. Scientists are now using supercomputers to understand what forces conspired to shape their orbits. They've designed a solar system with 2 large planets, close enough to fall under each other's gravitational spell. Each time the pair passes, their mutual gravity tugs them gradually out of orbit. Inevitably, they cross paths. One planet is flung to the outer reaches of the solar system. The other hurtles toward the sun, where it is captured. This is also the fate that would await a smaller planet the size of Earth, and with it would go the prospect of life.
What is exciting with regard to theory is that we are finding planets that completely defy our prior conceptions as to how planets would have formed. And that's the glory of science. We can reject, in part, some of the notions that were too narrow about how planets form, and we can now embrace a much wider range of processes that lead to planets.
Hostile solar systems may well be the rule in our galaxy. The question will fall to the next generation of planet hunters. They'll use an arsenal of new technology. This mirror, nearing completion at the University of Arizona, is 8 meters across. One of the largest in the world, it will be outfitted with advanced optics that will further the search for smaller planets. It's the brainchild of Roger Angel.
The bigger the mirror, the sharper the image you can make if you correct for the atmosphere. The curiosity about what's out there, where we live, are there other planets like ours? I think these are universal questions. The richness of the universe goes beyond our imagination, and it's telescopes like this that let us go out and find things that perhaps we could never have imagined.
NASA plans to launch a device into orbit around the sun at a distance beyond Mars. Known as an interferometer, it is a series of mirrors arranged along a line that combine their signals as one. This is a new breed of telescope, complete with infrared detectors that can read light reflected off the surface of planets.
The space-borne interferometer multi-mirror telescope, which would allow us for the first time to take a direct picture of an Earth-like planet. At first, it would just be a dot. Then you can take that dot of light and spread it out into all of its colors, blue through red, even into the infrared, and with that spectrum of colors, detect the chemicals that are making up the atmosphere of that planet. By detecting the chemicals, we can look for oxygen, methane, CO2, and so on, and those chemicals will be the signatures of life, if it exists, on those Earth-like planets.
I'm certain that Earth-like planets exist. I'm certain that if you put them roughly at an Earth-Sun distance away from its mother star, that water will exist in liquid form. And with 100 billion stars serving as essentially as 100 billion separate laboratories on which to run this experiment, I'm sure that life will evolve on some of them.
As for those other worlds we are now discovering, we populate them with the distant hope that the pulse of life is not our planets alone. As we extend our horizons, no doubt we will come to see planets and life itself from a whole new perspective.
From their point of view, their life might, for example, have hydrogen sulfide in its atmosphere, and oxygen would be hopelessly inappropriate. And they would say, gee, what's oxygen doing? That's poison. Whereas we, in looking at them and seeing hydrogen sulfide, would say, what's a planet doing with hydrogen sulfide there? That's a bad smell. We've got to come to terms with life being so much bigger than anything that we have recognized just by having one set of planets around and one that happens to be at the right temperature here.
Well, we've received hundreds of pictures from children of our planets drawn in crayon. It's quite wild.
We can only imagine what technology will someday reveal.
Temperature is right for water. Now, a lot of planets have one set of rings. This planet, you see, has two rings. They're orthogonal to each other. This is the planet Zeus. Everybody knows the planet Zeus. Here's a planet called Columbus. I don't know what that is. And every child has done something different. They didn't actually just copy each other. Here's the famous unknown planet, Lake of Mercury. This is a very brilliant child. This child thinks that there might be liquid mercury on this planet. Here's the famous planet Hand. Here's the planet whatever. You are here, in case you didn't know where you are. And then, of course, here's the planet with who knows what this is around it, some coronal hot gases or something. That's all about blob number one.
For about 20, 30 years after we stopped believing in Martians, there was a tendency to think that maybe the galaxy is a relatively lifeless place. But now that we're realizing there are planets out there and that there may be life out there, I think the galaxy is beginning to seem like something of a romantic place again, a place where there might be other intelligences and beings out there, perhaps something like ourselves, beings that we could communicate with over the centuries to come.
I would see human beings as occupying not a central place, but not a trivial place either, a sort of intermediate position. We have a place in the universe, we belong to it, we have emerged from the universe as part of a natural process. We're not freaks. But nor are we at the center either. I think that this sort of middle position is actually one to be celebrated, because I think we can feel that the universe is in some sense our home, that we're meant to be here.
Like an only child, we wish we had company. And we wish at the same time to be creation's one and only. As we continue to search for our place in the universe, all we know for sure is that our imaginations will guide our journey.
If what was called forth in creation was not just life on this little tiny speck, but life on this speck and that speck and another speck and another, then life has been called forth everywhere, and it would give meaning to our existence in not the way that we originally thought we wanted, to be special, but it would make us significant in being the same.
Well, I had one of my most amazing experiences as an astronomer looking at the Milky Way in the southern hemisphere. It was glowing, brilliant stars in the foreground, these massive dust clouds. I thought of all the other civilizations that might be floating in it at the same time. And I had a vision of one great galactic community. And I felt myself to be a citizen, not of Santa Cruz or the United States or Earth, but a citizen of the galaxy for the first time. And of course, I had to wonder whether or not we would ever fly around it and meet up with all of these other civilizations.